second audio session at SMPTE. A rare event to even have one, but we actually have a bonus. We have two sound sessions for you today. And both of these sessions have been sponsored by the Audio Engineering Society. SMPTE gave them a slot at the conference, which I think is really great. At the last session, we heard about how soundtracks are designed and what these people go through to design a soundtrack. But once you've got a soundtrack, then you have to actually play that soundtrack through a cinema sound system or a dubbing stage sound system. And that's what this particular workshop is about, talking about how to design that, and that it's a little bit more interesting than you might think. So I'm going to start off by introducing my two panelists. Over here is Neil Shaw from Menlo Scientific. This is Mark Roberts from Streamline System Design. A couple of bullet points from Neil's bio. He's an acoustics and facility design consultant in Los Angeles. He designs production, post-production, and exhibition stages such as sound stages, mixed rooms, Foley rooms, ADR, screening rooms, theaters. He's a fellow of the Audio Engineering Society and the Acoustical Society of America. He's the recipient of the SMPTE Samuel Warner Medal, which Walter Murch is going to get this week, but Neil got it a couple of years ago, which is really great. He's also the recipient of the Kenward S. Oliphant Memorial Fellowship in Acoustical Engineering, awarded by the Consulting Engineer Association in California. He's a member of the Institute of Noise Control Engineering, which is why he knows how to make such good noise. And he has served on the faculty of USC's Thornton School of Music and Southern California Institute of Architecture. And let me just get my intro points for Mark here. Mark is the Director of Engineering and Integration Services for Streamline Systems Design. They specialize in immersive audio facility installations. He's been a prime player in making the methods and products to aid the transition from film to digital, which is a good pedigree to have. He's done quite a bit at the Deluxe Technicolor Interoperable Test Center, the ITC. Any of us who've been involved with the industry testing that's gone on in Los Angeles has spent some time at ITC. He's also built television stations and satellite network hubs in his career, and he's done system integration for concert halls, showrooms, churches, airports, casinos, government boardrooms, and other industrial systems. And I'm proud to say that he was the systems integrator on the recent Cary Grant Theater upgrade to Atmos, which was done on the Sony lot, and that's how I had the pleasure of meeting Mark. So let's give a round of applause for our panelists. All right. Got a couple of slides just to kind of set things up here. Let's see if we can go click. There we go. So what is the stuff that really characterizes a cinema dubbing stage sound system as opposed to having it be a live sound system or another type of a system that's just done in an auditorium, like for live theater or something like that? And of course, there's a good answer to that, which we'll hear in a minute. We're going to find out about what characterizes today's soundtracks, which we heard some of in the last session, and why a well-designed sound system is so very important. So the characteristics of a cinema dubbing stage sound system. So its primary job is to reproduce sound that goes with moving images. I think that's pretty obvious. One of the main characteristics is that the main loudspeakers are behind a screen. It's got surround speakers on the walls, and if it's an immersive sound system, also on the ceiling. It's got subwoofers down under the screen usually. And in the vernacular, we often call such a system the B chain. You'll hear that referred to several times in our presentation today, the B chain. The A chain being the part of the cinema system which plays it out from the servers and out into the projector and everything else. The B chain is what produces the sound out into the room. What we have for a B chain is we have several components that kind of characterize it. We have a cinema processor, we've got routers, amplifiers, we've got, of course, loudspeakers, which can be either passive or active. We have a screen, which is a very important acoustical consideration. I call it the great white filter. And we have, of course, the acoustics of the room, which is very important in any sound system installation. Today's soundtracks, as we heard from the folks before, they're very full fidelity. They're often recorded digitally end to end, so they actually have quite a bit of juice to them. Even if it's not an action movie, you've got quite a bit of actual real organic sound, both sounds that the sound designers put in and the sounds the composer puts in. We have a lot of dynamics. One of the things that makes a sound system cinematic, or makes cinema is the dynamics, where you've got very quiet sections and then the big stuff comes and it really makes an impact and then it goes back down. So you've got a lot of dynamics that the sound system has to deal with. You've got very steep transients, transient being that quick change of sound, very high, usually associated with high frequencies, metallic sounds, things like that. You've got, especially in action movies, you've got like 2, 3, 5 minutes going at a time things are pretty loud and pretty bold. And the sound system needs to be able to put up with that and actually continue to reproduce. Those who are in the know that as soon as you start really exercising a sound system really hard, it heats up. And when it heats up, there's usually some kind of degradation to its ability to perform. So one of the things about a modern sound system is it has to be able to take a lot of level for a sustained period of time and continue to perform. We have a lot of density, we have complex waveforms, a lot of very high and very low frequencies, so it really exercises the entire frequency spectrum. And of course, the music is pretty amazing in today's soundtracks, whether it be orchestral or synthesized. A lot of times you have both, and as we know, synthesizers are capable of an octave below what you're most likely to get out of most orchestra instruments, and that really shows in some of our soundtracks. So there's quite a bit of challenge that the soundtrack is throwing at the sound system, and when we move forward to be thinking about what that system has to be able to do, it's got to be able to take all this dynamic range linearly. It's got to take this level. It's got to have an electroacoustic response that's really wide and really good. It's got to cover the auditorium well. No matter where you're sitting in the auditorium, you should be able to get a really good experience, and that's actually one of the tougher things to do in a sound system, is to actually do proper coverage. Of course, the room acoustics and treatment I've already mentioned. Each room that a sound system is put into, you really need to design the sound system for that room, because no two rooms are the same, and how a sound system with identical components may behave in one room is going to be very different, maybe that it behaves in another. And so the designer of the sound system has to take that into account. And you also have to install a sound system with maintenance in mind, because you're going to have to maintain it. I don't know how many of us have gone to theaters where speakers are blown out or distorted or different things, and nobody goes and maintains those things. Well, one of the reasons maybe not is it's pretty hard to do. And so part of the challenge of making a sound system is to actually make it so you can maintain it. And the other thing about a cinema sound system is that it's tightly calibrated to SMPTE standards, in this case ST 2096-1, ST202, and RP200, which those of us who've been working on the standards know those very well. Dubbing stage systems need to accurately reflect what the filmmakers are going to be mixing into the soundtrack. So when you're on that mix stage and you've done all this work to design something, and you're trying to make the right blends, and you're trying to figure out how to spread it and do all of the things that we do during mixing, the sound system has to be able to accurately tell you what that really is so that you know what you have. And that's a pretty big challenge, actually. On the other side of it, the sound systems in the cinemas, if they're done right, should accurately reproduce what went on in the mix stage. And what we find is that the less than great sound systems, shall we say, don't accurately reproduce what the people who mixed the film intended. And so you really don't get that cinematic experience from a less than good sound system. The sound system isn't really giving you the emotion and the dynamics that were actually built in. A great sound system, on the other hand, is really easy to listen to. Even in the loud sections of the movie, it's very pleasant on the ears. There's, little distortion, and it's giving you the dynamic impact that you're looking for, which I think is really key. On the other hand, a less than great sound system, when presented with a dynamic soundtrack, will often exhibit quite a bit of distortion and other artifacts. And sometimes when you're listening to that, you don't even really realize it's distortion, because it's not, like an electric guitar type distortion, right? It's a distortion that affects the harmonics. It spits things out of the sound system that actually aren't there, unpleasant artifacts. And a lot of people just go, oh, it's too loud, it's just too loud. But actually, what is happening in quite a number of cases is the sound system is just folding up and not really reproducing the way it should. And it actually has very unpleasant artifacts that literally push you away from the story that's being told. So one of the subtle little plugs I'm putting in here is a great sound system brings people to your dubbing stage or to your theater. And once you've been to a theater, or if you're a mixer, you've worked on a dubbing stage that really has a good sound system, that's where you want to go, and that's where you want to pay your money. So I think it's an important aspect of all this. So I'd like to have Neil Shaw come up now and give us a presentation. He's going to tell us about some of the considerations when you're actually designing these sound systems, both from the equipment perspective and from the acoustics and all of that. Neil?
Great. Hi, I'm Neil Shaw, but you know that, and I want to thank Brian for asking me to give this little talk today. Here's the moving image portion of the presentation. Okay, one of the most important aspects of the design is the selection of loudspeakers and the amplifiers, but also of importance is the acoustical design of the space. And we'll take a quick look at all these here, but this is not necessarily complete or comprehensive. But before we do, some quick historical notes. SMPTE has been here for 103 years. Vern Knudsen was here from 1893 to 1974, third graduate in physics from BYU. He was at the University of Chicago with Harvey Fletcher from Bell Labs. He was at UCLA from 1922 to 1974. But the talkies came about in 1927, 92 years. He was here when all of a sudden the shooting stages had to become sound stages, and theaters need to reproduce the sound. It must have been an exciting time. It's an exciting time these days, too. The goal, the suspension of disbelief. In other words, we don't want to know we're watching a movie. We want to experience the movie. We want the environment to be such that we're sucked into the story. We don't want to have the sound system interfere with that at all. This is the goal, except for maybe some documentaries and biopics. Our goal is to translate what was on a mix stage into a reasonable facsimile in the theater. So you want to build a B-chain for a cinema post-production room. Well, let's look at the budget. This is normally the thing that is never enough, but overrules any of the design considerations. Next thing you want to look at is how and what is the room to be used for? This leads to the required size, usually more than the space allocated. For example, I worked on the screening room in West Hollywood where we had to get a certain number of seats in a room. I mean, even though everyone had to kind of suck their stomach in to do it, we had to design the room to have a certain number of seats. And you have to understand that in a commercial cinema, the seats are sometimes the largest acoustical load in the room. Okay, so the use dictates the equipment fit out, which goes back to the size. Oh, and by the way, the cheapest acoustics is good space planning. You don't want to put the ore crusher next to the diamond cutter. Okay, well, one step in the design is that you can model the room using several of the, or any one of the commercially available acoustic and electroacoustic modeling programs, such as EaseCAD, among others. Okay, now this is a model not necessarily for a purpose-built space. Many times we're asked to, oh, we want to show movies in this space, and it's not built for that. So here's an example of a room where that was asked to be done. So once we know what we want to do in a room, we can begin selecting some loudspeakers to do so. And here's a model of the loudspeaker from the Ease program. Now, this is for what we use for a screen channel. Okay. One thing we want to know is how many do we need and how far do we want to throw, which in order to meet the required sound level, or L sub P as we say now, at the reference point. What kind of surround or immersive system we're going to put in, how many to meet the spec, what bandwidth, and how far is the throw, and does the size of the room allow for the proper implementation of the loudspeakers for that format. Now, sub-bass. I mean, I could speak for several days on this. How many and where do they go for best coverage? And you could get into a lot of trouble quickly here. Now, this is an almost random loudspeaker, but it was selected because of 90 by 90, 90 by 60 coverage, which was just a simple beginning, first cut, okay? Okay, now, today's soundtracks have limits and requirements. Screen loudspeakers can go up to 100 dBc plus headroom with 2/3 of the reference point. How do I get 105 dBc? When you commission the system, you get 85. We're 20 dB below full scale, and even with a limited engineering education, I can tell that we need 105 dBc there. The surround loudspeakers, we need 102 dBc. The immersive surround speakers, 105 dBc. Subwoofer choices, well, how much is too much? I know that my wife, who's a musician, says she wants more bass at all frequencies, but we have certain limitations here due to the standards we're trying to make the room. Now, let's take a look at a real measurement. This was a trailer measurement at one of the better reference theaters in town. The top curve is the peak unweighted sound level. Note the 128 dB L peak level at about 8 minutes 34:30. That's the top curve. With the equivalent LZ EQ, that's unweighted equivalent, over 1 second of 117 dB. Okay, and 94 dB, the LA EQ over 1 second. Now, the Z and A are very important, okay? And this is not the loudest soundtrack out there. But the nice thing is, even though you may have a temporary hearing shift, when you're done, your clothing will be dry cleaned at the end of the movie. And just to give you an idea of what these weightings are, dBA just cuts a lot of the low frequency energy, which in today's soundtracks, there's a lot of it. dBc is almost flat and Z is flat. So when people talk to you about sound levels and they say dBZ, dBA, this, you can understand what they're doing to it. And the baseline calibrations, the RP 2095 and the 2096-1 and -2 talk about this. Okay, so with that background, let's take a look at our initial selection here. We have 5 loudspeakers. They're aimed at the reference point. And we see that with the coverage we had there, we covered all the seats. Now, the difference in audio perspective will vary from seat to seat. Your mileage may vary here because you'll be off-axis or on-axis for different speakers at different times. Now, what a lot of people don't think about is the vertical coverage here. Now we see that we have most of the seats within our coverage, okay? But we see that a lot of the energy is going up where there's no audience. So in this application or this room, we might want to look at a room that has a little tighter vertical coverage, or even better, an asymmetric coverage that's wider at the bottom and narrower at the top of the seating. Okay, so let's look at a real cinema loudspeaker. Some people may recognize this, a data sheet. But this is a popular three-way cinema system for the screen channels. We see the horizontal dispersion is what we want, and the vertical dispersion is asymmetric as we require. Now that we have a preliminary loudspeaker selection for the screen channels, we can look at the power requirements for the amplifiers to get the sound out here. And we also note that this system can be used in biamp or triamp mode, which might be a consideration due to budget. So we're going to look at our the amplifiers now. It's important to understand that amplifiers and loudspeakers talk in different languages about their power requirements. Most amplifiers talk about output power in terms of the power for a sine wave input, which has about a 3 dB peak to average ratio. In fact, it has an exact 3 dB peak to average ratio. The AES amplifier spec uses a 6 dB peak to average pink noise. SMPTE now has a standard pink noise, which is generated by a Python script in ST2095-1, 2015. Use the correct factor to determine how big the amplifier should be. You don't want to have underpowered amplifiers because you'll drive them into clipping, which will generate a lot of high-frequency energy, which may cause the magic smoke to emanate from the compression drivers. And the goal of all our systems is once we have them installed and calibrated is that playback is at 7. Now, just a word about subwoofers. Subwoofers interact at low frequencies and can generate power alleys, which are shown in the top and bottom ones. And depending on how you space them apart, you can have dead zones off to the side. And now this is a free field simulation for subwoofers. Once you put them into the room and you have, let's say, massive walls, you get into mirror images, which makes things even more difficult. So there's been a lot of rooms where, depending on where you sit, there's no sub-bass, and in others, you don't need the pacemaker. One thing we have to remember is that we have humans as the end users in this room, despite all the measurement equipment we have. These are the standard ISO equal loudness curves. The bottom one is the threshold of hearing. You can see that we're more sensitive at about 2 kilohertz than we are at low frequencies. Why? Because over the evolutionary period, if we didn't hear the snap of that twig, we were lunch. At the top, you can see the threshold of feeling or threshold of pain. You can see another curve that starts off at about I can't read, about one line below the highest line, and it dips down quickly. That is called the threshold of annoyance. Okay? So in a lot of cinemas where we have an older population like me, especially those who have a hearing assistance, as soon as we get above their threshold, we're already above the threshold of annoyance. A lot of times, that is what is causing people to ask to have the sound or the fader turned down. Okay? And then we have the ST202 guidelines for the response of the system. This is from ST202 for motion picture, dubbing stages, screening rooms, indoor theaters, B-chain electroacoustic response. This is the goal. The room acoustics can affect this. Note the mid-frequency break that depends on the room volume. A lot of people don't take that into account when they commission a room, and it can make the playback in a cinema sound different from that on a dub stage. Now, this makes or breaks many cinemas. The acoustics. We have many masters here. In the real world, the room and its finish would be designed around a B chain, and we don't have to deal with owners or architects or interior designers. However, we are in the real world, usually when in a designer room, I find when everyone is equally unhappy, we're at the right spot. So at least a starting point which we can move from then. And then we can move on to implement what the major stockholder, the person paying, usually wants or needs. The acoustical design includes in three broad categories: the room acoustics, size, shape, and materials. The sound isolation, which is and that's insulation, which is a little different, which is the envelope design of the room. And finally, the mechanical system quieting. The architect manipulates the same things as the acoustician, size, shape, and materials, but normally we care about the materials and the size and the shape and a little different priority. These can be reconciled in many cases. As I mentioned before, the cheapest acoustics is space planning. Don't put the diamond cutter, once again, next to the the ore crusher next to the meditation room. In a multi-space facility, this can be expensive if ignored. How many people have been to the cinema and seen one image and heard 3 soundtracks? And we want to keep the HVAC quiet. There's nothing more that in an intimate moment in the film, when it's quiet and they're whispering, all you can hear is just the air conditioning. We are concerned with background noise, as I mentioned, which is needed for wide dynamic soundtracks. The reverberation time. We don't want the room to add its own signature to the sound. Intrusive noise, don't want to hear things happening in the lobby or the cinema next door. We worried about the walls to ensure that doesn't happen. Reflections and echoes in the room should be minimized, if not totally eliminated as much as possible. Resonance and rattles in the construction of the building. A lot of cinemas have suspended grid ceilings. Nothing like hearing a little rattle up there during certain parts of the movie. And then the background noise from not only the air conditioning, but the projector. So we look at all these things and try to reconcile them with the architectural design. Now, there's 3 major acoustical finishes that we can deal with. One is specular reflection, which you can get off a hard surface. Next is diffusion and absorption. We want to avoid specular reflections because they will just add something that was not present in the original mix. We don't need to put diffusion in there. We want to make the envelope or the room as neutral as possible so that the intent of the soundtrack is faithfully reproduced without any room coloration. Okay, so let's go back to our original first cut. We see a lot of energy is hitting the sidewalls. We want to minimize that. We want to absorb it, okay? We don't want to have specular or diffuse reflections from there. And in a room like this, especially from the ceiling, because so much of the energy is just directed up there. Okay, now we spoke about background noise a little bit earlier, and this is what's called the noise criteria curves. These are standard curves to give you a neutral sound, even though at the higher NC levels, it's not neutral, it's obvious. The bottom curve is the threshold of hearing. ANSI S12.2 gives recommendations for the NC level for screening rooms, first-run theaters, and commercial cinemas. That was just updated and reissued this year. And we use that in the update we just did on RP 141, which is the SMPTE recommended practice for noise in a cinema. And that's available at the gift shop on your way out. And finally, there's some industry standards for the level of reverberation in a room. The larger the room, we can see that we have the solid lines or the limits for the reverberation based on a room volume, and the dotted lines are that for a smaller room, okay? Once again, the reverberation can detract from the sound in a room. We don't want to add any more reverberation, and the sound mixers have added to the music or to the dialogue or the singing or the Foley did to the steps in the hallway. And when we do it all right, you don't know it's there. Thank you very much.
We're now going to hear from Mark Roberts about what it actually takes to install this stuff in a room and what the considerations are for that. As I mentioned, Mark recently did the Cary Grant Theater Atmos upgrade. It's one of the biggest dubbing stages practically in the world, and a lot of challenges to that. So, Mark?
How's everybody doing today? You guys want to build an Atmos system? Well, it can be a real challenge. So you'll come up with multiple plans and what type of system you can afford. There's many moving targets where what the building is, what you want out of the system, and what your end goal is. There is a lot of high costs in this, and that's where you decide on what kind of system you want to have, whether it's something that's going to be very accurate, or is this something that's going to simulate what's out in the field? And your budget will kind of tell you that, but it's also the direction you might want to go. So if you're building a dub stage like the Cary Grant, you're mixing for what's out there. But you might use other systems so you can accurately hear it. And then, of course, there's the deadline. And can you get all this done in that timely fashion? And everybody in here knows that the movie industry or our industry moves really quick, and we got projects that are looming, and we got to get it done so they can start that mix or start that QC or et cetera. And it's just not only sound systems, it's all of our type of systems that we build. So, can the space handle what you're going to be building in there? I mean, a lot of people want a lot, but some rooms you can't do it because of the size. It may not become a cinematic dub stage. It might be for television. It might be small enough for a QC room. Is the building already structurally prepared for the load? Well, look at the picture. Because you are putting a lot of weight up there. And even look what's above our heads here with what's being hung. Is it strong enough to do that? Do you have enough power? Is your panel big enough? Remember, you're going to be putting in a lot of amplifiers, so it's going to get warm in there. So you got to cool that down. And yeah, you still got a projector in there. And is the room the correct size? I know Dolby has to go through a lot to approve rooms. And a lot of people want to squeeze something in. But that's the reality of it. Can you do it? All right, okay, here's the other thing. Can the room handle the energy? Just like what Neil was saying, was the sustained volumes in that room. Is your room going to come down? It's just not only stopping the rattles, but can that high amount of energy be handled in that room that you're building? Because guess what? The speakers have been behind the screen, and we had these little speakers around the side. Now we're putting in a top fuel dragster in your room, and you got subs in there, and you know, it's going to get loud. The room comes alive at different frequencies. When you sweep it, you're going to be surprised, and you're going to start hunting the rattle. And the other thing is, you're going to start hunting to see if there's any structural failures. Is it safe? That's the biggest thing too, guys, is it safe? Did you already isolate the building so it's a room in a room? You know, that's the good old air gap. But is that room inside of a room strong enough? Or are you just hanging stuff? Even if you did it, you should think about doing a little bit more to make it strong. Okay, Dolby has certain standards for dub stage, and the room will tell you if you can, you can do it. You'll have, you're trying to get the green in all the boxes. Sometimes you don't. One of the things that just recently happened is we were trying a manufacturer's subwoofer, and it wouldn't get approved. But Andy Potvin told us to put all the subs together, and then it got approved. Just how how it coupled together. Then the subs work. Again, handle the load. Structural engineering. Make sure it's safe. You got hard points. So you're not only looking for acoustics, but you're looking for strength. And you have the solid hard points to attach from. And this is where you need to hire in experts to help you on this end of it. I mean, we're all engineers, but sometimes you need the structural guys to come in too, and the steel people. Handle the heat. You're gonna be adding amplifiers, it's gonna get warm. Do you need more circuits? Yes, you are. You might have to do panel upgrades, which sometimes will happen. And you won't realize that cost is gonna be there unless you do the load calcs and start looking at these other things around you. Yes, you want this big sound system, but you gotta kind of look around and can this venue do that, okay? And obviously you're putting in the projection booth, so you're gonna need more AC and more cooling. You're doing a lot more than just buying a sound system. So when you put this in, that's the Cary Grant Theater, by the way, expect to use multiple trades. It's just not speakers, it's just not wire, big part of it, but you're gonna have to get your electricians in there. You're gonna have to get sprinkler people, fabric people, mill work. So all these things add up in the budget, even though you just say budget X for the sound system and the amplifiers and everything, but what about all this underlying thing? And then I'm sure you guys have built houses or remodeled them or been in projects where, yeah, it's gonna cost this much and then it's only gonna take 2 weeks, but it's just gonna add up. And you gotta have that, you better bring a little bit more cash. And you're gonna have varying complexity. So you're gonna have some surprises because it gets busy overhead. If you want the speakers down or do you want them hidden? Do you wanna build a truss around the room? Or are we gonna just go off of hard points? So all these different things you gotta think out to see if this is the right way to go. Okay, there you go.
All right, thanks, Mark. Thank you very
Do you want to show
much.
some slides?
Yeah, we're going to just talk a little bit about a few of the points here, and then we're going to take a look at some more slides about the actual Cary Grant installation that we got, which are cool. One of the things I think I heard from both of you is that you can't underestimate what it really takes to get the job done. In fact, it's hard to overestimate it. You always find once you get into it that there's a lot more to it than maybe somebody originally thought, right? And one of the things I think about that both of you said is that when you have a sound system in a room, that room becomes like a living thing. That room just all of a sudden is talking. you know, and it's not just the loudspeakers, it's everything, the whole room is talking to you. And this is part of that visceral experience that we get from cinema, so that's the really positive part of it. The design consideration part of it is that you have to actually, you know, take that into consideration as how you actually physically put that together to make it work, right? Either of you want to comment on that?
Right. It's the type of thing, you can have a good sound system in a bad room, and a bad system in a good room, and sometimes the bad system in a good room will have a better experience for you. Okay, but I want to touch on what you mentioned about how time and money. All right, I learned a long time ago the 90-90 rule of construction, and this applies to both time and money. First 90% of the project takes 90% of the time. The last 10% takes the other 90% of the time.
But I think that where, at least in my experience, some of the cinema owners or even dub stage owners maybe fall down in their work. They think that they're going to be saving money by not hiring an acoustic designer or a team of acoustic designers to get the job done, because they think, oh, I can't spend money on this and I can't spend money on that, and I need to bring it in for this bottom line. But the fact of the matter is, if you don't spend that money and get the right talented people like you have here to do the work, all of a sudden you found out that you just spent a whole lot more money than you thought, because you didn't get the advice that you needed, you didn't get your room prepared the way it needed to be, you didn't get a sound system that was actually designed that can do the job in that particular room that you happen to have, right?
Well, it's the type of thing, never enough time to do it right, always enough time to do it over.
And that's basically what happens, right? It's just like anything else. You try to cheap out, and then you find out that it's costing you more because you got to do it all over again, right? So preparation and planning for these things will save you a lot of money in the long run.
Well, and it's always better to do it right the first time, and it's not that much more expensive or time-consuming, especially if you have to do it all over again. I know that in LA we're very fortunate that many of the cinemas I go to with my wife, she picks them, of course, I've had a pleasant experience, okay? Except in one theater where they still had the silver screen for 3D, but they were showing a 2D movie.
Yeah, I think one of the things that we've all talked about in both of these sessions is the fact that most of the cinemas that are out there, even the ones that claim to be upper end, are playing our soundtracks in varying degrees to close to what they were. Many are playing them nothing like what they were. I think one of the big things that got me into being interested in all of this, and probably you guys in a way too, is you go to the neighborhood theater and you see a movie. In my case, it was back when Pirates of the Caribbean first happened. Pirates of the Caribbean was mixed on the Cary Grant Theater at Sony, and I knew what the soundtrack sounded like. I went out to a local movie theater, which will remain unnamed, and it was absolutely nothing like what it sounded like when we mixed it. I mean, absolutely nothing like it. And this all of a sudden made me realize, oh, yes, we've really got a problem here. So many of you know I've spent many years in standards trying to work toward understanding more about what the sound systems need to do, and we now have a working group in SMPTE who's going to tackle actually making some actual specifications for what these sound systems need to be doing. But is there anything you think we can do about the theaters that are in the field right now, except ask them to go spend a bunch of money? I mean, we do like an acoustic tune-up, if you will? Like, could a theater owner hire one of you to come in, and even though you're not going to get like the world's best system, but you could improve what they have and at least make it to the best level it could be?
Well, you can always diagnose and evaluate a facility and then put your recommendations together. But I find, I propose and the owner disposes. So, we can tell them what they need to do and whether they need to want to or have to is,
Well, sure, you can't make people do things, but what I guess I'm thinking is like, if we want to try to do upgrades of things in the field, if the only choice is spending a bunch of money, well, then it's obviously not going to happen. So we need to find some place where we can do something that will give the system a tweak and at least bring it up, to the best it can be, right? At a reasonable cost. Does that make any sense, or is that impossible?
it makes a lot of sense, except they don't want to shut the facility down and lose the income. It may not be compatible with the existing structure. Mark mentioned that we don't want it to fall down. That would not add to the experience.
Well, I think you can always improve loudspeakers maybe a little bit. You could, the amplifiers that just can't get enough poop, you could buy an amp that might do a little better, stuff like that. I'm going to take a minute here to look at some slides from this Cary Grant theater build. This is a very large theater. It's, I don't know, half again bigger than this room at least, and it's a dubbing theater. And so in order to get started here, obviously you have to consider everything you're going to do, and scaffolding is a fairly obvious thing that you have to pull off. So they started off with all of this scaffolding to try to get up to where they needed to be. And I'll let Mark speak to some of this because he was actually walking on those scaffolds.
So what we did here is we're building a dance floor, and that's a place where we're going to be working off of up into the ceiling. Now, all that ceiling there was fabric, and what was above that was steel in our hard points. All that fabric was just tacked onto wood, but that wasn't the safe way for us to go. We went on to the structural steel in that room. It was a domed room, so the structural steel was still part of a room in a room. Now, if you look down at the bottom of the picture, you'll see another platform there. The console is underneath that. So what we did before any of that came up is we built a safety platform for the console and then wrapped it up because the guys didn't want to move it out of there. Then we built our dance floor on that work level up there.
And you can go ahead.
Yeah, so there it is coming together.
These are some of the scaffolds that run along the walls so that you could go in and put in the surrounds and get those bolted in. And you'll also see that we've got a scaffolding there. That's the other side of the theater.
So if you look at this fabric, you can go to the next slide too.
Okay.
You look at that, and then you look at that. What they did was that was the method of the stapling, not the track system. And when you're looking up there, you could see a piece of that white stuff, and then you could see up into the ceiling. So this was peeled back right there, and that is how we got our speakers up into.
What do you mean by that? The
Well,
left
that
side or
was
the
our-
right side?
So that was our access point right there to put all of our steel up above. Our speakers would be hanging down below that, so we had to peel that back. So the reason why I'm bringing up the fabric is here's an existing site, and we don't want to damage it. Like it's always easy to tear everything out and redo it, but the Cary Grant is architecturally a beautiful room, so we had to be careful at what we were doing here. Even though that doesn't look that careful, it was quite delicate.
And this view kind of shows you looking back now. We're really high up in the theater. We're on that platform now where we're above that, and these are the speakers actually being hung from the ceiling, and how that's done. So it's kind of fascinating to see it actually from this angle. And again, these are the runners for the speakers along the side. Here's a shot looking up at the scaffolding that was there to get these speakers that Mark just mentioned. They had to peel it back. They had to put all this steel above that to hang these speakers, and then they actually had to hang them and aim them correctly and do everything that needed to be done. So it really quite a job. This is kind of a, go ahead.
And one of the things that you don't see here is the amount of lasers we used in measuring and coming within, we tried to do the tightest tolerances we can and try not to move any of the speakers away from the Dolby Dart in any direction. And if we had to, because of an architectural feature or it couldn't work out in a position, we had to go back and get approval. So all these points are approved points. And if you notice, it's just a little pipe coming down there, but there's a lot more going on up above.
Exactly.
So,
you take us through this next series, Mark. You gave me these slides yesterday.
Yeah.
You tell me what's going on with these.
So what this is we had an issue with the subwoofer. We didn't hang it inside the room, but we needed to put two
I want to
subs-
say these are the subwoofers that are for the surround speakers in an immersive system. They're not the ones that go under the screen.
Yeah.
In an immersive sound system, you use subwoofers to increase the bass response of the surround speakers. So go on.
So we were going to go the method of hanging them in the room, but it just wouldn't look good. So we brought them up above because the fabric is Guilford and Maine, so it's transparent. But we were starting to look at it. Here you got this big 218 box, right? And how does an engineer get to it if it's up in the ceiling? So what we did and designed and worked with Adaptive is we came up with a tilting mechanism, and we built a platform around that sub. It's just facing down into the room. So if any of the drivers, you lose them, all you have to do is tilt the thing and then take the drivers out and replace them, because usually the box doesn't go and the wire doesn't go in there. It's usually, if you're going to cook something, it's going to be the drivers. So we were thinking of safety and can the engineers access the gear? And that's one thing to look at too, because if you have all this stuff hanging in a room, you probably need to get to it one time or another, because something will go wrong. And then you have to think about, do I have to set up scaffold, or would it be easier just to walk up and do something? Yeah, it cost a little bit more, but it made it safe for the people to work on it. Oh, this is us hauling speakers up. We had a pulley system.
These I believe are the ceiling speakers, right?
And if you look above, there's the subwoofer on the tilt mechanism, and there's the platform anchored to it. Instead of just, we could have come off the hard points of the box, but we came up with that.
Another angle on that. And here's the folks muscling it into shape.
And that's what it was like up above. So we actually used the hangers, the Unistrut to hang it, to slide the subwoofer box down a track, because there was so much up there we couldn't get along. So we built train tracks for it to slide over to where it needed to go sit. And right there, they were the front mounting speakers, which was a larger speaker. But the reason why you're seeing all this steel is it's a room inside a room, but it's an old sound stage. So what we had to do was, there was a facade. Just everybody's probably seen movie sets and how that looks. That's that front, like little pieces of plywood. So what we had to do was build steel all the way back inside the room. We had to go back in time, is what we did, we had to cut through the Cary Grant and find a place that would give us strength that we could build off of. And then we sealed that whole thing up again to keep the acoustical integrity of a room in a room. But we needed to make it safe and strong. And so, you can't really see it in the front of the room in the corners, but those speakers are sitting there just like those other ones, just a little piece. But you don't see all the steel that goes behind it.
Yeah, so this is something you don't get to see when you go to your movie theaters, that the speakers behind the screen are actually mounted, in this case, in a very well-constructed baffle wall. And this is a side view of that whole situation. So it's really, you can see the subwoofers underneath there. Gives you a pretty good idea how that's done. And then this is actually just a quick little movie going around the room. You can see how everything kind of got mounted at the end of the day after all of this scaffolding and all of this stuff. And now we've got the screen speakers ready to go. And that crew that's up on the lift is about ready to put the screen over those speakers. And which is, of course, you know, when you've got that you're pretty much done, or very close to done,
Yeah.
with at least the mechanical portion. And then all of the, comes the calibration and everything else. So this is gives you a pretty good idea of what this room's about. I think it pans up to show what goes on in the ceiling speakers that are up there for the 2 Atmos rows that you saw in Neil's drawing, and overhead speakers.
It looks like that shot pretty much close to the mix position, so you can see how everything is aimed to you.
Right.
And then there's some back corner speakers, which are the IMAX speakers, and there was an additional overhead for the IMAX, so they can do Dolby, DTSX, and IMAX in this room.
Yeah, so that little video gives you a pretty good idea about that.
I'm dizzy
This just
now.
shows how the speaker, the screen is now being put over those speakers, and pretty much finishing that up. And here's the amplifier racks, which I just included for fun. And as Mark says, it takes a lot of good food to do this work. So do we have any questions from the audience for our panelists here? I see someone getting up.
John Turner. I think it's inevitable that direct view LED screens are on the horizon and are going to spread like wildfire just due to the economics of them. So what are your plans for front sound stacks with direct view screens?
I plan to use them as soon as they develop them.
The screens or the speakers?
It'll probably need to be integrated.
Not sure how you do that.
Well, if I knew how, it would be out there already, but I know that Samsung has a demonstration theater out in Winnetka.
Winnetka.
That's right. Yeah. Yeah, but I think what they're doing is firing from the bottom and the top.
Well, that you know, when I heard about that, I thought about the old Sigma screen and the split system they had with the horns above and the woofs below. And you know, I think that eventually we will get something where it's integrated into the LED panels. But the problem is at the low frequencies, the movement required will cause a visual distortion.
More of a question for presentation theaters. How do you handle the difference in the acoustics of the room between the audience that comes in the summer wearing t-shirts and shorts and the winter audience that comes in with the heavy fur coats, hats, and everything else with a lot more sound absorbing?
Let's only work design rooms that are in Southern California. But the whole idea is that when you pick the seat, you want it to look the same, whether there's someone in it or not. And the difference between the absorption of a person in a t-shirt and someone wearing a fluffy Michelin Man coat can be substantial, but I would say get a better HVAC system so they don't have to bundle up.
Yeah, but they wore the coats to the show. Where do they put them? Because they usually sit in the theater and wear coats.
Well, I think your more general point is that a room behaves quite differently empty and when it has people in it, and whether those people are wearing shorts and t-shirts or whether they're wearing fur coats. But a sound designer can really only do so much. I mean, you have to design for like the real-time space, which is when people are in the theater, right? You don't design for an empty theater. You design for one that has people in it. Go ahead, Bill.
One more comment
Oh,
on that.
sorry.
If you choose the seat properly, the acoustic load in a room should not change appreciably whether you sold that seat or not. Now, the amount of clothing on the person is going to change, I think, the savings or the absorption of that person about maybe 10 to 30%, but in acoustics, 3 dB is all that matters, okay? and that's double or half.
So we spoke about this theater as being capable of presenting Dolby Atmos, DTX, and IMAX. Are there any compromises or differences in requirement for those different sound systems that might speak to how the room acoustics are managed, the absorption or the reverb, or is that relatively uniform between the different systems?
The room acoustics in a dub stage is the same no matter what you're mixing to. The room acoustics in each of the theaters where it's shown may differ depending on who owns it and the attention they spent on it. Now, in a dedicated IMAX room, they're pretty particular. Dolby's particular too. I'm not that familiar with DTX, but
I guess the question there would be, are they differently particular?
Yeah. We're being told we're out of time, but
yeah,
that's not
but-
because Bill's question's not important. I think in a really general sense, when you, a multi-purpose theater like the Cary Grant, where you're trying to mix IMAX and you're trying to mix Atmos and you're trying to mix different things in, I would say yes, there is acoustic considerations so that it can handle all of those different formats. Usually in a cinema setting, you only have one of those formats at a time. But in a dub stage format, you may have multiple formats. So I think that's a salient point. It's a little above what we can go into right now, but the answer is yes. All right, I'd like you all to give a round of applause for our panelists.